Hello students, welcome to Doubtnut. Our question is, an HCl molecule has rotational, translational and vibrational motions. If RMS velocity of HCl molecule in its gaseous phase is V, m is the mass and Kb is the Boltzmann constant, then the temperature will be mv square divided by n Kb. We have to find the value of n in this expression. So let's suppose this is our HCl molecule and the value of Vrms for this molecule is given to us, that is V bar, and we know the formula for calculating our Vrms, that is equals to under root with 3RT divided by m, or we can written as under root with 3 Kb T divided by m. So this is the relation of Vrms. Now if we solve this further, then V bar is equals to root with 3 kBT by m, where Kb is Boltzmann constant and T is absolute temperature. So if we squaring both sides, then we get our temperature expression is 1 by 3 V dash square into m by Kb. So this is the final expression we get. Now we have to compare this expression from this one. So we can see that the value of n comes out to be 3. So our correct answer is 3. Thank you.
क्वेश्चन क्या है अपना, फॉर ए गिवन गैस एट 1 atm pressure RMS speed of the molecules is 200 meter per second at 127 degrees Celsius. At 2 atm pressure and at 227 degrees Celsius the RMS speed of the molecules is. एक गैस गिवन है जिसका जो मोलिक्यूल्स का स्पीड 127 डिग्री सेल्सियस पे अपन को गिवन है और 227 डिग्री सेल्सियस पे अपन से पूछा है बेसिकली. ठीक है, तो आरएमएस स्पीड मेरा क्या होता है, वी आरएमएस रूट 3 आर टी बाई एम. ठीक है, तो इसमें बेसिकली इस फॉर्मूले में देखूं तो मेरा चेंज किस में हो रहा है, टेम्परेचर में चेंज हो रहा है. तो मैं ऐसे बोल सकती हूँ भाई कि V1 जो है अंडर रूट 3 आर बाई एम, टेम्परेचर 127, इसको मैं केल्विन में कन्वर्ट करना चाह रही हूँ तो मैं 273 ऐड कर रही हूँ बेसिकली. ठीक है, तो मेरा V1 का वैल्यू मुझे गिवन है 200 रूट 3 आर और इसका वैल्यू कितना आ गया मेरा 400 बाई एम. ठीक है, अब सेकंड के लिए अगर मैं लिखूं, मुझे V2 फाइंड आउट करना है अंडर रूट 3. अब अगर 227 को मैं केल्विन में कन्वर्ट करूंगी, 227 में अगर ऐड करें अपन 273, सो दैट विल बी 500 बेसिकली, है ना. ठीक है, अब मैं क्या करती हूँ, इन दोनों को डिवाइड कर देती हूँ. फोर 400 और इसका रेसिप्रोकल. ठीक है, तो बेसिकली एम से एम कैंसिल, इससे ये कैंसिल, जो बचा वो अपना ये है 200 बाई V2 और ये 400 बाई 500. सो जो मेरा V2 है दैट इज 4 बाई 5, 200 5 बाई 4 मीटर पर सेकेंड. ठीक है, अब रूट 4 को मैं 2 लिख सकती हूँ, तो 200 बाई 2 रूट 5 मीटर पर सेकेंड. सो ये मेरा कितना आ जाएगा 100 रूट 5 मीटर पर सेकेंड. ठीक है, तो अपना कौन सा ऑप्शन करेक्ट हो गया? ऑप्शन सी इज करेक्ट. ओके, थैंक यू स्टूडेंट्स.
Hello everyone. The temperature at which the root mean square velocity of hydrogen molecules equals to their escape velocity from the earth is closest to. So here the Boltzmann constant is given. Avogadro number is also given. Radius of the earth is this and gravitational acceleration is this. So if I talk about the escape velocity, so escape velocity is equals to under root of 2g r, where r is the radius of the earth and g is the gravitational acceleration. Now we know that root mean square velocity is vrms is under root of 3rt by m, where m is the molar mass and r is the universal gas constant, right? So I can write r is equals to Boltzmann constant into Avogadro number. So you can just put it here. So you'll get 3 k Na by this, right? Okay, so it is given here the escape velocity and the root mean square velocity of the hydrogen gas molecule are equal. So we can also write it as 3 kt by small m, where small m is the molecular mass. Very simple. Now you can just equate the two. So I will write here under root of 3 kt by m is equals to this. So you can square both sides. So after squaring both sides, you will get, right. Now if you see the question, in the question the temperature at which this happen is asked, right? So I will write here T is equals to gr. So this will be multiplied here with inverse, like 1 by this will be multiplied here. So I will write this. So this will be the temperature 2gr into m by 3 kt, right? Now you can just put the values of g, radius of earth, molecular mass of hydrogen by 3k. Now I will multiply and divide with Na and Na, right? Now we know that R is Boltzmann constant time Na and molar mass is molecular mass times of Avogadro number Na. Now you can just put the value here. So 2 into g, we know that gravitational acceleration is 10, and if I talk about the radius of the earth, it is already given in the question. If you see, it is 6.4 into 10 to the power 6. So I will write here. So this is the radius of the earth, and now we will write the molar mass of the hydrogen. So we know that the molar mass of the hydrogen is 2 grams. So in kilogram, I will write 2 into 10 to the power minus 3 in division 3. So K into Na is the gas constant 8.3. So this will be the final expression. So if you will solve this, you will get 1.01 into 10 to the power 4 Kelvin as the answer. So this will be the temperature at which the root mean square velocity will be equals to the escape velocity from the earth. Now you could see the option. So option C is the correct one. 10 to the power 4 Kelvin will be the temperature at which this condition will be satisfied. Simple. Thank you. Hello everyone. An ideal gas is enclosed in a cylinder at a pressure of 2 atm and temperature 300 Kelvin. The mean time between two successive collisions is 6 into 10 to the power minus 6 seconds. If the pressure is doubled and temperature is increased to 500 Kelvin, the mean time between two successive collisions will be close to. So here we have to find out the mean time between two successive collisions when the pressure is doubled and temperature is increased to 500 Kelvin. So we know that mean time is directly proportional to volume by velocity. So from the gas equation we know that PV is equals to nRT. So if I talk about the volume, volume is nR by Tp. So volume is proportional to Tp, right? And if I talk about the velocity, then we know that the velocity is proportional to under root of temperature, right? So we can just put the values of temperature and velocity, volume and velocity. So I will write mean time is directly proportional to T by P into under root T. So you could see the mean time is directly proportional to under root T by P. Okay, so here in the question it is said that the temperature is increased to 500 and the pressure is doubled, right? So if I talk about the T dash by T, so that will be equals to under root of T dash by change in pressure plus P by this. So just put the value. So the change temperature is under root 500 Kelvin if you see here, and initial temperature was under root 300, and initial pressure was P and change pressure was 2P. Okay, so this will get cancelled out and you will get under root 5 by 3 into half, right? So you will get the T by T dash is equals to this. So in the question it is given that the mean time between two successive collision was earlier 6 into 10 to the power minus 8, right? So if you will see here, so you will write T dash equals to 6 into 10 to the power minus 8, that is T, into under root 5 by 2 root 3, right? So this will be nearly equals to 3.8 into 10 to the power minus 8. So you could write this is nearly equals to 4 into 10 to the power minus 8 seconds. So you could see the option, the correct option here is B, 4 into 10 to the power minus 8 second. Thank you.